The National Electrical Code, or NEC, does not mandate the use of specific colors for identifying voltage systems like 120/208 volts or 277/480 volts. There's a common misconception that black, red, and blue are required for 120/208 volt systems and brown, orange, and yellow for 277/480 volt systems, but this is not an NEC requirement. The NEC focuses on the identification of grounded and ungrounded conductors and equipment grounding conductors, but does not specify the colors for different voltage levels in the way many people believe. The identification of grounded conductors typically involves the use of white or gray insulation. Grounding conductors are usually bare, green, or green with yellow stripes. Ungrounded conductors, often referred to as hot wires, can be any color other than white, gray, or green. However, best practices and local codes may influence color choices to enhance safety and clarity in electrical installations. It's important to distinguish between NEC requirements, industry best practices, and local electrical codes, as these can vary. For instance, while the NEC allows for a wide range of colors for ungrounded conductors, it's common in many commercial and industrial settings to adopt a color coding system that helps electricians quickly identify the voltage level of a circuit. This practice is not driven by the NEC itself, but by a desire to improve safety and reduce the risk of errors during maintenance and troubleshooting. Firstly, consider a scenario where an electrician is working on a complex electrical panel with multiple voltage systems. Without a consistent color coding system, it could be challenging to quickly identify which conductors are energized at 277/480 volts and which are at 120/208 volts. This increases the risk of accidental contact with a live wire, potentially leading to serious injury or equipment damage. Secondly, effective color coding can significantly speed up the process of tracing circuits and identifying faults. For example, if a lighting circuit powered by a 277-volt system is malfunctioning, an electrician familiar with the color coding scheme can quickly locate the relevant conductors in a panel and begin troubleshooting. Thirdly, the NEC does provide specific guidelines for identifying the function of conductors, regardless of voltage level. For example, Section 200.6 of the NEC details the requirements for identifying grounded conductors, which must be white or gray. Section 250 covers grounding and bonding requirements, specifying the use of green or bare conductors for equipment grounding. It's important to note that the NEC allows for re-identification of conductors in certain situations. For instance, a conductor that is originally installed as an ungrounded conductor can be re-identified as a grounded conductor by permanently marking it with white or grey tape or paint at all termination and splice points. However, this is generally not recommended for grounding conductors, as it can create confusion and increase the risk of errors. It is imperative to consult the latest edition of the NEC and any applicable local codes to ensure compliance with all electrical safety requirements. The NEC is updated every 3 years, and it's essential to stay informed of any changes that may affect electrical installations. Local codes may also impose additional requirements that go beyond the NEC, so it's crucial to check with the local authority having jurisdiction. When working with electrical systems, always follow safe work practices and use appropriate personal protective equipment, or PPE. This includes wearing safety glasses, gloves, and insulated tools. Never work on energized circuits unless absolutely necessary, and always de-energize and lock out/tag out the circuit before beginning any work. If you are not a qualified electrician, do not attempt to perform electrical work. Electrical work can be dangerous, and it's best left to the professionals. Always hire a licensed and experienced electrician to perform any electrical work in your home or business. In addition to the NEC, other standards and guidelines may be relevant to electrical installations. For example, the National Fire Protection Association, or NFPA, publishes a wide range of standards related to fire safety, including NFPA 70E, which covers electrical safety in the workplace. It's also important to be aware of industry best practices, which may go beyond the minimum requirements of the NEC and other standards. These practices are often developed by experienced electricians and engineers and are based on their knowledge of what works best in real-world situations. Furthermore, consider the application of these concepts in different types of electrical systems. In residential wiring, for example, the color coding is typically simpler than in commercial or industrial settings. In a typical residential electrical system, black is used for hot wires, white for neutral wires, and green or bare for grounding wires. However, even in residential wiring, it's important to verify the voltage of each conductor before working on it, as miswiring can occur. In commercial and industrial settings, the electrical systems are often more complex, with multiple voltage levels and a wider range of equipment. In these settings, it's even more important to have a clear and consistent color coding system to prevent errors and ensure safety. Some companies develop their own internal color coding standards that go beyond the requirements of the NEC and local codes. These standards may specify the colors to be used for different voltage levels, control circuits, and other types of wiring. The NEC provides guidance on conductor identification in Article 200 and Article 210. These sections cover the requirements for identifying grounded conductors and equipment grounding conductors. It's important to review these sections carefully before performing any electrical work to ensure compliance with the NEC. Another key aspect of electrical safety is proper grounding and bonding. Grounding and bonding help to protect people and equipment from electrical shock and fire hazards. The NEC provides detailed requirements for grounding and bonding in Article 250. It's crucial to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. In addition to the color coding of conductors, other methods can be used to identify electrical circuits. For example, circuit breakers and fuses can be labeled to indicate the circuits they protect. This can be helpful for troubleshooting and maintenance purposes. It's also a good practice to create a detailed electrical panel schedule that shows the location of each circuit breaker or fuse and the loads it serves. This schedule can be invaluable for future maintenance and troubleshooting. When working with electrical equipment, it's important to follow the manufacturer's instructions carefully. This includes using the correct tools and equipment, following proper wiring procedures, and performing regular maintenance. Ignoring the manufacturer's instructions can lead to equipment failure, electrical shock, or fire. Electrical safety is a shared responsibility. Everyone who works with or around electrical equipment should be aware of the hazards and take steps to protect themselves and others. This includes following safe work practices, using appropriate PPE, and reporting any unsafe conditions to the appropriate authorities. Continuous education and training are essential for staying up to date on the latest electrical safety practices and requirements. Electricians and other electrical workers should participate in regular training programs to refresh their knowledge and skills. The NEC is not a design manual, but rather a set of minimum safety requirements. It's important to consult with a qualified electrical engineer or designer to ensure that the electrical system is properly designed and installed. The design should take into account the specific needs of the application, as well as all applicable codes and standards. Furthermore, consider the importance of arc flash protection. Arc flash is a dangerous phenomenon that can occur when a short circuit creates an arc of electricity in the air. Arc flashes can generate tremendous amounts of heat and energy, causing serious burns, injuries, and even death. The NEC requires employers to perform arc flash hazard assessments and to provide employees with appropriate PPE to protect them from arc flash hazards. NFPA 70E provides detailed guidance on arc flash hazard assessment and protection. Understanding the relationship between voltage, current, and resistance is fundamental to electrical safety. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This simple formula can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. It's also important to understand the concept of power, which is the rate at which electrical energy is used. Power is measured in watts, and it can be calculated by multiplying voltage by current, or watts equals volts times amps. The NEC contains numerous tables and examples that can be used to determine the proper size of conductors, of recurrent protection devices, and other electrical equipment. For example, Table 310.16 provides the allowable ampacities of insulated conductors based on their size, insulation type, and ambient temperature. It's important to use these tables correctly to ensure that the electrical system is properly sized and protected. In addition to the NEC, other standards and guidelines may be relevant to specific types of electrical installations. For example, UL standards provide requirements for the safety of electrical equipment. IEE standards provide guidance on the design and operation of electrical power systems. It's important to be aware of these other standards and to follow them when applicable. Remember that electrical safety is an ongoing process. It requires constant vigilance, continuous education, and a commitment to following safe work practices. By working together, we can create a safer environment for everyone who works with or around electricity. Color coding, while not strictly mandated by the NEC for voltage levels, serves as a valuable tool in promoting electrical safety and efficiency. Consistent application of color coding practices combined with adherence to NEC guidelines and local codes helps ensure that electrical systems are installed and maintained in a safe and reliable manner. The lack of a specific NEC requirement for color coding voltage levels highlights the importance of understanding the code's intent and the need for qualified professionals to make informed decisions based on the specific application. By prioritizing safety and employing best practices, electricians and engineers can create electrical systems that are both efficient and safe for all users. So, while you may hear that brown, orange, and yellow are for 277/480 volt and black, red, and blue for 120/208 volt, that is just not true as a requirement in the NEC codebook.